Hello everyone, welcome back to Maths with Twinkle. In today's video, we are going to solve exercise 1.1 of chapter 1 real numbers from the class 10th NCERT Mathematics textbook. This exercise is mainly based on prime factorization, HCF and LCM and will try to solve every question step by step. So keep your notebook and pen ready and try each question with me before I show you the solution. Now let's begin. Question 1 asks us to express each number as a product of its prime factor. The important thing to remember is that we have to continue factorizing until every factor becomes a prime number. Let's start with 140. 140 is divisible by 2, giving us 70. 70 is again divisible by 2, giving us 35. 35 is divisible by 5, so it gives us 7. And 7 is a prime number. Therefore, the prime factorization of 140 is 2 squared into 5 into 7. Now let's factorize 156. 156 divided by 2 gives 78. 78 divided by 2 gives 39. 39 divided by 3 gives 13 and 13 is a prime number. So the prime factorization would be 2 square multiplied by 3 multiplied by 13. For this number, we keep dividing with prime numbers. First, we divide the number by 5. It gives 765. Now 765 divided by 5 again, then it gives 153. 153 divided by 3 gives 51 and 51 divided by 3 gives 17. Now 17 is a prime number. So the prime factorization of 3825 will be 3 square multiplied by 5 square into 17. For 5005, divide the number by 5, we get 1001. Now this number is divided by 7, that gives us 143. Now 143 divided by 11 gives 13 and 13 is a prime number. So the prime factorization will be 5 into 7 into 11 into 13. And finally 7429. This number is divisible by 17 giving 437. 437 is divided by 19 gives 23, which is a prime number. So the prime factorization for this number would be 17 multiplied by 19 into 23. Now in question number 2, it says that to find HCF and LCM of each pair, and then we have to verify an important relationship, which is HCF multiplied by LCM is equals to product of these two numbers. First, we need to find prime factors for these numbers. So 26 would be 2 into 13 and 91 would be 7 into 13. Here the common factor is 13, so the HCF would be 13. For LCM, we take every prime number with its greatest power. So the LCM would be 182. Now let's verify it. 13 into 182 is 2366 and 26 multiplied by 91 is also 2366. Therefore, the relationship is verified. Here, you also have to find the prime factors for the given numbers. So, 510 would be 2 into 3 into 5 into 17 and 92 would be 2 into 2 into 23. Here, the only common factor is 2. So, the HCF is 2. For the LCM, we take the greatest power of every prime factor. That gives us 23,460. Now for verification, multiplying HCF and LCM gives 46,920, which is exactly equals to the product of these two numbers. The prime factors of 336 would be 4 times of 2 into 3 into 7 and 54 would be 2 multiplied by 3 times of 3. The common prime factor are 2 and 3. For HCF, we take the smallest power, so the HCF would be 6. For LCM, we take the greatest power, that gives us 3024. The verification also works here. Question number 3 is similar, but this time we have 3 numbers. The method is exactly the same. As question number 2, first we need to find the prime factors for the given numbers. So 12 would be 2 multiplied by 2 multiplied by 3, 15 would be 3 into 5 and 21 would be 3 multiplied by 7. So here is only common prime factor is 3. So HCF is 3. Now for the LCM, we take all the prime factors with their greatest power. That gives us 420. Here all 3 numbers are prime and there is no common prime factors. Therefore, the HCF is 1. The LCM is simply their products, which is equals to 11,339. Here 8 would be 3 times 2, 9 would be 2 times 3 and 25 would be 2 times 5. Again, there is no common prime factor in all three numbers, so the HCF is 1 and the LCM will be the product of these three numbers, that is 1800. Now question number 4 gives us the HCF directly, so we don't need to find the prime factorization again. As we know, the product of two numbers is equals to the product of LCM and HCF of that two numbers. Here HCF and both the numbers are given, so we simply put the values in the given expression. Then we get 9 multiplied by LCM is equals to 306 multiplied by 657. This LCM would be 306 multiplied by 657 divided by 9. This will becomes 73. Now LCM is equals to 306 multiplied by 73. So LCM would be 22,338. Now let's look at a reasoning question. It says that can any natural number that ends with 0 if it is written as a power of 6? For a number to end in 0, it must contain a factor of 10 and 10 can be written as 2 into 5. But the prime factor of 6 are only 2 and 3. There is no factor of 5. Therefore, 6 to the power n can never end in 0. This is question number 6. Whenever a question asks us to show that a number is composite, look for a factor other than 1 and the number itself because in composite numbers there are more than 2 factors. Now look at the first part. Take 13 as common, then it would be 13 in bracket 7 multiplied by 11 plus 1. Here 13 multiplied by 7 multiplied by 11 is 77 plus 1 is 78. So it would be 13 multiplied by 78. Since it has product of two numbers greater than 1, then it is a composite number. In the second expression, 5 is common to the first term and the second term. So 5 in bracket 7 into 6 into 4 into 3 into 2 into 1 plus 1. This would be 5 multiplied by 1009. Therefore, both factors are greater than 1, so the number is composite. Our last question is an application of LCM. Sonia takes 18 minutes to complete one round while Ravi takes 12 minutes. They start together at the same point and move in the same direction. We need to find when they will meet again at the starting point. We need the first time when both complete a whole number of round. So we find LCM of 18 and 12 and the LCM would be 36. Therefore, they will meet again at the starting point after 36 minutes. And that is the complete exercise 1.1. In this exercise, we used prime factorization, found HCF and LCM, used the relationship between HCF and LCM, and solved application based questions. If you understood these questions, you are ready to move on the next part of real numbers. Don't forget to like, share and subscribe. Thank you.